So this is the example. It says a 50-50 slurry of solid gibbsite and water, 1000 tons per hour each. That means it will be 1000 tons per hour gibbsite and 1000 tons per hour water. At 25 degrees centigrade and 1 bar has to be screened. Use geometric PSD mesh type between 10 to the power minus 6 and 1000 millimeter range. It has been given. Use an RRSB distribution function with dispersion parameter 0.8 and D63 of 140 millimeter. So that is how the inlet specification of feed material has been specified. So you have only one particle size distribution over here. So you remember you have to use PSD attribute J. So in this case, J is 1. And then come to problem specification. You have two problems to solve. One is screen the feed using US Bureau of Mines selection function with 300 millimeter screen opening. Wet content is fed at the upper level of the screen and resulting mass flow rate of fluid should be twice that of the solid in coarse entrainment. Okay. And then the second problem is use a double deck screen with ideal and whiten selection functions. So here it is a double deck, means we'll have over 1 and over 2. Okay, 2 streams as the overflow. So first deck screens with cut size of 300 millimeter, where 38% of core stream is fluid. Whereas in the second deck screens with a cut size of 50 millimeter, where 58% of inlet fluid entrains with core stream. The sharpness, offset of fines and beta of whiten functions are 3, 0.2 and 0.1 respectively. Okay, so this is how the example has been set. So we will solve it one by one. For that, let us go back to our system. So for the time being, let us delete them. Let us define the components over here. We have two things. One is gibbsite and water. And do not forget, gibbsite should be solid. Okay. And then we have to choose the method. Choose the method solids. Run. Okay. Now go to simulation. And you have to first you have to go to setup, say stream class, and globally you have to choose mixed substream with Cl solid with PSD. And then go to solid PSD, define geometric PSD mesh. That's what it is. Geometric PSD mesh between 10 to the power minus 6 and 1000. So it is 10 to the power minus 6 2000 millimeter. Create the PSD mesh. Created. Now go to feed. You have to define So what is the temperature and pressure? Temperature is 25 degrees centigrade, 1 bar pressure. So 25, this is 1 bar, and water is 1000 tons per hour. So it is 1000 tons per hour. Okay. Now go to Cl solid. Here it is 25, 1 bar, mass flow of 1000 tons per hour. Particle size distribution, you have already selected PSD, and then distribution function, it is RRSB with 0.8 dispersion parameter and D63 140. So this is RRSB, dispersion parameter 0.8 and D63 140 millimeter. Calculate, and it has calculated. Okay. So this is the cumulative weight fraction. Okay. Now, so feed has been defined. Now we have to define the parameters of the screen device. So let us double click. And we don't have anything over here, so just delete the row, because we will need multi-deck device when we solve the next problem. For this problem we'll have only one deck, and we have only US Bureau of Mines selection function, which we'll choose over here. And the moment we choose US Bureau of Selection function, then directly we go to size of screen opening, and the size of screen opening is 300 millimeter. So this is 300 millimeter, and then weight content is fed at the upper level of the screen. So this is upper level and mode is wet. Resulting mass flow rate of fluid should be twice that of the solid in the coarse entrainment. That means the amount of fluid or the mass flow rate of fluid in the coarse will be double that amount of the mass flow rate of solid in the coarse. So let us see how it defines. For that, let us go and find out over here. This is the one which we find. That is mass flow rate of fluid in the coarse by mass flow rate of solid in the coarse. So this will be twice of that. So this L coarse actually is 2. Okay. So we have to use coarse load with entrainment factor 2. We will choose coarse load with entrainment load 2. Okay. And never forget, we have to use solid only. Now you can run. Okay, now results available. You can go and find out the results in the result summary. So these are the streams. So you have first check the mass flow rate whether the entrainment load has been calculated properly. So here you will find in the overflow the mass flow rate of fluid is 310831 and the mass flow rate of solid is 155416. So this ratio is actually 2. So we have chosen course load of 2. So that's what it is. That's how the water and give site has been loaded. Okay. Now for solid, as you know, the overflow will have the coarse particles. So it will not have finer particles. So you will see the entire finer particles will be shifted in the underflow. And in the overflow, this range will be 10 to the power minus 23 and all. So it is almost 0. You may consider it as 0 only. So overflow will not have much of fine particles. Now let us see from where the overflow begins to have coarse particle. So for that, just go below and here you will find that this is the portion where the underflow doesn't have any flow of these particles. And see the range? It will be somewhat around 300 millimeter. Okay, so this is the screen opening that we had, 300 millimeter. So above 315 millimeter, it has nothing. The underflow has nothing. And the entire coarse product will come over here. So all the particles above 300 millimeter, it has come to the overload. And all the particles below 300 millimeter, they have mostly gone to the underflow. Okay. That's how the screening device has segregated the particles. Okay. Now let us go to the next problem. So we shall use the same feed. So let us use a manipulator, that is duplicator. And we will need a second screen. So this is another screen that you will have. This one we shall reconnect to the duplicator. Okay, and then we'll connect it over here, and we'll connect it over here. This is the underflow, and if you see the problem statement, it's a double deck screen. Okay, so you will have 2 decks. This is the first deck and this is the second deck. So we will rename them as over 2 and this is over 3. Fine. And then under 1, and this is under 2. What else? The first deck will have ideal and second deck will have white and selection. So let us go to the selection. First deck is ideal and the second deck is whiten, right? Yeah. Now you have to put the cut size. So what are the cut size? The first deck cut size is 300 and the second deck it will have a lower cut size, so it is 50. So 350. So it is in millimeter. It is 300 cut size and this is 50. And then the sharpness parameter of whiten function, sharpness is 3, offset of fine is 0.2 and beta is 0.1. So this is 3, this is 0.2 and this is 0.1. Okay. And there is nothing to choose over here. No operating level, no this thing. We have to choose the entrainment specification over here. Now let us see what are the entrainment specification. In the first deck it says 30 weight% of core stream is fluid. 30 weight% of core stream is fluid. So let us check which one we have to use. Here it says specified fluid fraction in the core stream. So it says 30% of the total stream in the quartz is fluid, or else this by this should be 30%, that is 0.3. So we have to choose coarse frac and the value is 0.3. So here we have to use coarse frac and this is 0.3. Okay, and what is the second one? It says second deck screen where 50 weight% of inlet fluid entrance with the quartz stream. 50 weight% of inlet fluid. So here you will see specified fraction of inlet fluid to quartz stream. Okay, that means 50% over here. So Y course will be 0.5. So we'll choose quartz split and 0.5. So it is quartz split and 0.5. Okay. So everything specified. Now let us run. Yeah, so it has run quickly. And let us go to the stream. So two more overflow stream has come over here, over 2 and over 3. So let us see. First see the mass flow. For the first case, that is over 2, we have taken 30% of the core stream is fluid. So look at that. So the fluid is over here, it is 65904.6, and the total core stream will be this one, 219682. So if you calculate, you will find it to be 0.3. Similarly, you can calculate for this over 3 also. Now let us go to the particle size distribution of over 2 and over 3. Now see, for over 2, the finer particles will be 0, right? Up to what? Up to here again, you'll find the size range around 300 millimeters. So below 300 millimeter, nothing will go to the overstream because it is an ideal case, ideal overstream. Okay, so everything above that. And for the over 3, that is having Whiten function, the cut size is 50 millimeter. We can compare under 2 and over 3. So remember, division between over 3 and under 2, they have been guided by the Whiten function. And it is a limit because over 2 has kept the particle size up to 300. So this is one cut size. And the second cut size with over 3 is somewhere around 50. So somewhere around here. So under 2 will have absolutely nothing over 300. Very few between 300 to 50 range, because this is the portion which has mostly gone into over 3. And below this, everything has gone to underflow of the second screen. Okay, so that's how it is divided. So with that, we end this lecture. I hope you have enjoyed it. We'll come back with yet another interesting lecture soon. Thank you.